In this lesson, we're going to be looking at line symmetry in polygons. We're going to focus on relating the property of symmetry to the classification of triangles, quadrilaterals, and other polygons, determining which polygons have lines of symmetry, and determining the number of lines of symmetry in polygons. The outcomes we're going to cover are: describe and illustrate the line symmetry in triangles, quadrilaterals, and regular polygons. Identify and explain an application of the properties of polygons in construction, industrial, commercial, domestic, and artistic contexts. And solve a contextual problem that involves the application of the properties of polygons. So a couple of definitions to start. The first is line symmetry. Line symmetry is a type of symmetry in which an image or object can be divided into two identical halves by a line of symmetry. It's basically a mirror going down through the middle of an object. And a line of symmetry is a line that divides a figure into two identical halves. Sometimes it's called a line of reflection because it looks like we're looking at a reflection through the line. Or sometimes it's referred to as an axis of symmetry. A line of symmetry and an axis of symmetry because we often refer to lines as axes in math. So basically, line symmetry is any time we can basically look at a mirror image of an object. So we're going to look at how we can determine the number of lines of symmetry now. Jerome is building an inlaid tabletop. He knows that symmetry in designs is pleasing to the eye. Which shape shown will provide the greater symmetry, the rectangle or the parallelogram? For the rectangle, with two pairs of equal sides and all right angles in a rectangle has two lines of symmetry. So we can see in our diagram here that there are two lines of symmetry, a vertical line and a horizontal line. If we cut our rectangle through the vertical line and then place a mirror there, we're going to basically get the opposite side. And if we place a mirror along the horizontal red line, we're going to see the same thing. We're going to see the exact same shape appear in the mirror image as what we see right now in front of us. For the parallelogram, with two pairs of parallel sides and opposite sides equal, the parallelogram has no lines of symmetry. And we'll see that here. Okay, there's no line you can draw through a parallelogram that will create a mirror image of that shape in through your line of symmetry. Okay, if we were to take one of those lines and place it in a mirror, what we're going to see is either a trapezoidal shape or what will essentially be a funny-looking hexagon. So there's no way we can draw a line of symmetry or basically a mirror reflection of half of this shape so that we get the what we see here in the diagram in the reflection. If we're looking for an object with the most symmetry to create our tabletop, then the rectangle has more symmetry, so it would be the better option in this case. So we're going to look at another example. Jillian is making a quilt out of triangular pieces of cloth. She wants to know which type of triangle will give her the most lines of symmetry. Okay. First, the perimeter of the triangles will be 30 centimeters, and the side measurements will be whole numbers. So what we want to know first is, can the triangular pieces be equilateral triangles? Can they be isosceles triangles? Or could they even possibly be scalene triangles? So we're going to look at them on a case-by-case basis. Is it possible to have an equilateral triangle? Well, for an equilateral triangle, some of the properties include that all sides are equal. So if the perimeter is 30 centimeters, then we can have an equilateral triangle, and we can determine the side length by dividing the perimeter by the number of sides, which is 3. So 30 divided by 3 means that each side in my equilateral triangle is going to have a length of 10 centimeters. Okay, so there's only one way to draw an equilateral triangle with a perimeter of 30 centimeters, and that's with a triangle with side lengths of 10 centimeters each. So that's an equilateral triangle. So sure, an equilateral triangle can have a perimeter of 30 centimeters. How about an isosceles triangle? In isosceles triangles, we have 2 equal side lengths. And here are some examples with 30 centimeter perimeters. So you can see here that if we have a perimeter of 30 centimeters, we have 2 equal side lengths, well, we can have a side length of 1/8 and 1/8 for our 2 equal side lengths, which means that our third side would be 30 minus 16, because 8 plus 8 is 16. 30 minus 16 would be 14. So my side lengths would be 8 and 8 and 14, which will add together to give you 30. Or we can have 2 side lengths of 9 centimeters each, and our third side would have a measurement of 12 centimeters in that case. And we can go on down through the line, as you can see there in the table. There's one key point to note here, and that's that any 2 sides combined must be larger than the third. Okay, so if we add any 2 sides together, we must have the 2 of them added together equal larger than the third side in a triangle. So for instance, if I said that I had an isosceles triangle with a perimeter of 30, and 2 of the sides were 3 centimeters each, the third side would be 24 centimeters, because 3 plus 3 plus 24 equals 30. The problem with this is that 3 plus 3 is only 6. It's nowhere near 24. So that means that we can't have a combination of sides of 3 centimeters, 3 centimeters, and 24 centimeters, even though the 3 numbers add up to 30. And that same rule applies for scalene triangles as well. Any 2 sides in a triangle must add up to be greater than the third. Okay, with scalene triangles, we also know that no sides are equal. And here are some examples of scalene triangles that have 30 centimeter perimeters. So side 1 could have a length of 12, side 2 have a length of 10, and side 3 have a length of 8. You'll notice that all 3 sides are different in length, and any 2 sides added together is going to be larger than the third. And if you add up all 3 sides, you're going to get a value of 30 for the perimeter. So it fits all the criteria for a scalene triangle. So we have 4 examples here. There could be more than this if you want to give it a try yourself. We might want to make sure that we have a whole number side lengths, and we want to make sure that none of them are equal, and we want to make sure that any 2 sides will be larger than the third. So what we've discovered is it doesn't matter if we have an equilateral, isosceles, or scalene triangle. Any one of them will work for creating a triangle that's 30 centimeters in perimeter. Which type of triangle has the greatest symmetry? So we'll go through the 3 triangles in the same order we just looked at the side lengths. So the first type of triangle would be an equilateral triangle. And an equilateral triangle has 3 equal angles as well as 3 equal sides. So in an equilateral triangle, there are 3 lines of symmetry. We can see the 3 lines of symmetry here. we always have one of our lines of symmetry passing through a vertex and going through the opposite side, going halfway through the opposite side of each of our sides. So 3 lines of symmetry are possible in an equilateral triangle. In an isosceles triangle, we know that 2 sides are equal, and of course 2 angles will also be equal. In a situation such as this, we're going to end up with just having 1 line of symmetry, which you can see in this diagram here. It's an isosceles triangle because the bottom right and bottom left angles are equal, and the left and the right sides of the triangle are equal, but the third side and the third angle are not equal. So an isosceles triangle will only ever have 1 line of symmetry. Now a scalene triangle has no equal side lengths or equal angles. As a result, there are no lines of symmetry possible in a scalene triangle. And we see that in this diagram. There's no way you can put a mirror or a line through this triangle so you get the same thing on both sides of that line. It's just not going to happen. So which triangle had the greatest symmetry? The equilateral triangle had the greatest symmetry. All right, so the summary of this is that a line of symmetry divides a shape into 2 equal halves. So it doesn't matter which way your line is, whether it's vertical, horizontal, or it could even be a diagonal. What it must do is divide our shape into 2 identical halves. And this is something you're going to come across if you do any examples with regards to symmetry, is that a regular polygon, so that's like our equilateral triangle, a square would be an equilateral, or sorry, would be a regular quadrilateral. Then we have regular pentagon, regular hexagon, regular octagon, and regular any kind of shape. Okay. For any regular polygon, it has the same number of lines of symmetry as the number of sides or the number of angles, because they're both going to be the same number, in the polygon. So for instance, if I had a regular pentagon is a 5-sided figure, that means I must have 5 lines of symmetry. So that is something we're going to come across when we do some questions during our question sets.